Advanced Financial Modeling, Topic 12, International Finance, Learning Objective Number 7. We're going to compute the return and volatility improvements from switching from a domestic portfolio to a globally optimal portfolio. So let's go to the spreadsheet and take a look at the setup we have. I have here the means volatilities of cash, the S&P 500, EAFE, which is a developed market foreign stock index, and EMA, which is a emerging market stock index. And I have estimates here, reasonable estimates at the time for these assets and reasonable volatility estimates. And if you have a portfolio that's 100% domestic equity, you get a 7% mean and 15% vol. I have some correlations over here. And what you see here is the portfolio mean, the sum product of the weights and the means, and the portfolio volatility, M-mult transpose WSW to the 1/2 power, where W is the vector of weights, S is the covariance matrix. However, you also see that I didn't actually create a covariance matrix. I did that shortcut where instead of putting the covariance matrix in separately, I created a covariance matrix here using vols times transpose vols times correlation matrix. And you can see you do get the portfolio volatility of 15%. Now, if you invest in this portfolio all your life, say for 40 years and put $12,000 a year in that portfolio, you will wind up with a portfolio mean of 7% and that vol of 15, you'll wind up with $2.39 million. Now the question is, could you do better by opening yourself up to a globally optimal portfolio? So to do that, we can run Solver. Let's first reset these weights to 25%. It's always better in Solver to set up or start with equal weights or less extreme weights before running it. And what we want to do is try to find a portfolio with the same mean, 7%, but a lower vol. So can we still get $2.3 million, but less risk that that number could be less? So we can do data, solver. We want to minimize portfolio volatility by changing the weights. And we have a constraint that the sum of the weights is equal to 1, that's 100%. And we want to make sure we have a constraint that the mean of that portfolio is equal to 7%. And we're going to run solve. We have a solution. So you can see that you can create a portfolio that has the same mean as the S&P 500, but we can get over 100 basis points less vol, which will make this number here, the same expected mean, a lot less or a lot safer. Then we can also try another way of optimizing this portfolio. What if we run a solver that tries to maximize mean for that level of vol? So let's go ahead and run solver and do that. We want to maximize mean. Add a constraint that the vol is equal to the same vol as stocks, 15%. Run solver. And looks like we can get 758. So that would be a 58 basis points improvement in return. And again, it was a 1.52% improvement in vol. And the last thing we can do is say, well, what if we choose that globally optimal portfolio that has the 758 mean and the same vol of US stocks? Well, that extra 0.58 basis points of mean means that at retirement, you'd expect to have 2.7, almost 2.8 million versus 2.4, an extra $400,000 at retirement. So it'd be a $388,000 improvement. So that's significant amount of money for the same amount of risk. So in this section, we talked about the advantages of going from a domestic portfolio to a globally optimal portfolio.